Well, hello everybody. I think we could make a start now. We've got quite a few members online. I have had one comment come through from one of the members asking me to speak up, so I'll try and do that, and hopefully the technology will work well with us. Some of you may already be aware of how the webinars operate, and on the left-hand side of your screen there is a chat window. If you have a question that arises during the presentation, if you could type your question into the chat window, we'll do one of two things. We'll either address the question immediately as we're going through, or if it happens to be a question that requires quite a long answer, we'll most likely decide to continue with the presentation and go back to that question at the end. So I hope that works for everybody. So on the left hand side you'll see a chat window, and just type your questions in there if you have one. So a very good afternoon from me, and a welcome to the Voltimum webinar series. My name's Ian Richardson from ABB, and I'll be the first presenter in this session today, and a colleague, Steve Hare from iLighting, is going to continue the topic of today, which is energy efficiency in buildings. Okay, so let's make a start. And that's me. You don't necessarily need to see my face, but anyway, that's what I look like. Energy efficiency in buildings. It's a pretty important topic these days, and it's being addressed quite well globally. And there's a pretty good reason for that. If you look at the global scale, buildings are contributing to about 41% of energy consumption. The total energy consumption of about 41% of it is attributed to buildings, and about 21% of greenhouse gases. Of that figure, roughly 30% can be attributed to lighting. So lighting is an area which is concentrated on quite a lot to see if there's ways that we can conserve energy and also hopefully save cost. When we look at a building automation system, we're really considering beyond the lighting system as well. Lighting is just one portion of what a automation system is capable of doing, and you can see the list there, which is not necessarily a totally extensive list, but a control system such as KNX, and KNX is one of the ones that we will certainly talk about today. You can do lighting control and regulation, of course. KNX can also talk directly to heating, ventilation and cooling systems. There are products available that will accept the KNX protocol straight into the device. Blind and shutter controls is very common as well. You've got security, you've got energy and load management. Naturally there's various visualization techniques and products which are available, and so on and so forth. So we look at the total concept of trying to automate a building can be done on the same platform. For many years we may have had a system which would be doing our lighting controls. We'd have a separate system for our blinds and shutters, and yet a third system for doing other things such as your HVAC system. It's quite possible now to have it all under the same umbrella, and this is where a product such as KNX, or I shouldn't call it a product, it's not a product, a protocol such as KNX is capable of addressing all of these various parameters. And so as we can see here, there's quite a variety of different considerations in a building, and all of it is able to be done on the one platform, this platform being KNX, for example. One of the reasons that it's been very successful in the global scale is KNX complies with an IEC standard, an international standard. This provides a number of advantages. Number one, it means that no manufacturer can get in there and create their own little variation of what KNX is, because obviously you can't change the standard. So a company that I work for, ABB, we manufacture products which are compliant to the IEC standard, and they carry the KNX label. You could have brand X, Y and Z that are also producing products which are compliant to KNX. The really important thing is that because we all comply to the same standard, that means that all of these products will effectively live on the same bus system, and they will all operate. In fact, they're guaranteed to operate, because the KNX Association in Brussels have actually tested it, and they stand behind it and say that a compliant product will work with another compliant product. What this does for the contractors, and I expect a lot of you are contractors, if you're involved with something like KNX, it means you're not tied to one manufacturer. That's a bitter pill for me to say, because obviously I would love you to buy ABB products. The point is, you don't have to. You can buy ABB, brand X, brand Y, brand Z. It's all going to work on the same system. So now you've got choice. You can actually go to whichever manufacturer you're happiest with, pick the one that's got the product that suits the particular application you're looking for, and it will all work. So it's a really good point to take into consideration. Looking at areas where we might be able to save some energy and therefore save some money, this table here shows you different aspects of a building control and the amount of savings which are possible, and this has all been backed up by research from a variety of places, including some universities in Europe. As we can see here, if you do an automation system incorporating the lighting, it's possible to save up to 58% of your energy costs associated with lighting. So this is a really significant value. You can see there it's the highest value. So this is the one that we're going to concentrate on as far as this presentation goes. So we picked the easiest one. The greatest potential savings can be made in lighting, so that's the one that we've decided to concentrate on. So around about now, I'm going to hand over to my colleague Steve Hare. Steve is with iLighting, as I mentioned earlier, and he'll continue the presentation and talk a little bit more specifically about what we can do as far as lighting controls. Over to you, Steve.
Thank you, Ian, and hello everyone. Thanks for tuning in. Can someone just let me know, can they hear me okay on the microphone before I go into the presentation? Thank you, John. Great. Okay, I'll continue from there. Okay, so as Ian said, I'm going to focus on the lighting. So firstly, I'll talk a little bit about dimming, and then about what can be done with building controls and some of the benefits. So when we talk about lighting controls, one of the main benefits it offers is the ability to dim and switch the lights on and off. Dimming lights allows energy consumption to be reduced, which, of course, reduces running costs and reduces the carbon footprint of the installation. Dimming can also increase lamp life, depending on the light source, but fluorescent and LED lighting, dimming is always beneficial. Dimming LED light sources also has the added benefit that as you dim the light, the efficiency of the light source actually increases. So as you can see from this graph, we can see the relationship between forward current, or LED current, and the relative light output. So we see here the red line shows that at 700 milliamps you have 100% of your light output. Now if we reduce that drive current or LED current to 350 milliamps, we have now 56% of the light output. So it's slightly more efficient than it was at 700 milliamps. Now also bear in mind that this data is taken from a laboratory where the junction temperature of the chip was kept constant at 85 degrees C. In practice, as you dim the light, that junction temperature is going to reduce, which also increases the efficiency. So in practice, your efficiency will be even higher at 350 milliamps. So moving on to some of the control system options for lighting. The most basic form of control, but very effective in the right application, is time dimming or switching off of the lights. The user can program exactly when lights should be on and how bright they should be on a daily basis. This automated control mitigates human error. For example, someone could leave the office and leave the lights on all evening. Using a time clock and to automatically switch the lights mitigates this waste of energy and cost. Here you can see this is an installation at a university where time-activated dimming has been used. So these lights at this university campus have been programmed to dim down to 50% output at 10 PM through to 6 AM because the usage at this time is minimal. This allows the owner to save approximately 33% of their energy, which they wouldn't have done had they not have chose to dim. Here is a classic picture which we see very often of a city skyline, and you can see all the lights running at night time when you can guarantee most of those offices have no one in there working. And it's only really with timed building control that you can have these switched off on a regular basis and really get close to that 58% energy saving that Ian talked about before. So the next one, presence detection or motion sensing, is another option for control. Many of us use this in our gardens with security lights where the light switches on if someone walks close to the proximity sensor. But motion detection can be used much more widely than this and can be very effective in interior lighting as well. This option again mitigates human error by switching off or dimming lights when they are not required. They will also give you a guaranteed reduction in energy consumption. In application, the control system will normally allow you to program the lights to suit the application. So let's look at some scenarios. For example, you've got a corridor in an office. So corridors have a high volume of traffic, but people only use them for a short period of time as they're moving from room to room. Therefore, you can consider the resting state of the lights to be around 20%, or could be lower, could be higher. And then when it senses someone, it switches to 100%. But because they're only in this hallway for a short period of time, it only has to switch to 100% for 30 seconds or so. And then after that it can dim back down. Unless it senses someone else in the corridor, it will stay at 100% until there's no one there and it'll go back down to 20%. So a second option, this scenario is for a library. So here you've got areas that may not be occupied for long lengths of time, but when they are occupied, the person will hang around for a long period. Therefore, you may consider the lights being off until someone is detected, but then leaving them on at full brightness for 30 minutes or so, to allow people to browse in full brightness without having to wave their hand at the motion sensor. The next option is daylight harvesting. So daylight harvesting is the process of tuning the light to adapt to the natural sunlight that filters into the room. These systems can vary in sophistication where each light may act individually, or they may be controlled in groups and all work from the same light sensor or work from numerous light sensors. The light sensors feed back information on ambient light levels to the control system, which then dims or switches off the lights in the room. This allows large energy savings to be made and for the room to be evenly lit. So let's look at this example. You can see in a classroom it's very bright on one side and a lot darker on the other side. So the lighting may tune itself. So at this current state you may find the lights above near the window are on at 0%, but then moving across these ones may be at 30%, and at the far end of the room they could be at 60%. And that's what they will be at for that period in time. A cloud could come over, the light could reduce, and those levels could all reduce and then increase again. Those levels would increase and then reduce again when the sun comes out again. So another option, which is controlled dimming. This is to do with setting scenes within a space. If a room is used for multiple purposes, the lights can be pre-programmed to dim or even change colour to suit the different requirements of the various tasks. Although this does encourage dimming to take place, the main benefit really for controlled dimming is improved quality of lighting. So here's a few examples again. So let's look at a living room. We all use living rooms for several tasks which could all benefit from slightly different lighting. So consider this living room that is lit using 3 lamps. We've got a floor lamp and then 2 table lamps. So for, say you have guests you're entertaining in the room, you probably want all the lights on 100%. But then later on you might be watching television in which case you don't really need the floor lamp on, and because you're focusing on the television, you don't want the extra light from the lamps, so you can dim those down to 50%. And then maybe that should say scene 3, sorry. Scene 3 you could be set for reading, so you turn most of them off, you just have the floor lamp next to where you may want your favorite reading spot, and there you go, you're saving energy because you've got the light dimmed and you've got 2 lights off. So moving on to the next one. So lighting control via a touchscreen or remote device like an iPhone, or sorry, a smartphone or a tablet is very much linked to the controlled dimming option. Having this facility allows the user to conveniently control all the lights from the one location and easily switch between the predefined scenes for that space. And it just gives the user extra control to tune the light to however they want it at that period of time. Sorry, I just saw there's a question there from Matthew. The control scenarios you just presented, corridor and library, are great in concept but not cost effective. Again, that really comes down to a commercial decision. It's certainly an option which can be done, and as we're all switching to electronic luminaires, it becomes a much more viable option. But it really comes down to your customer's budget and what they want to achieve. So the next one, which is constant brightness, this is the final option. So constant brightness control, although it has no perceivable difference to the user, constant brightness control controls the light output all the time. So what it does is it controls the brightness of the light source to emit a constant light output over time, opposed to the light output from the lamp diminishing over time. What this is doing is compensating for the maintenance factor used within the design. This is an easy way to reduce energy consumption without impacting on lighting compliance to the applicable standards, and also increasing the lamp life as well. So if we just look at this graph, you can see, so any lighting design should be carried out using a maintenance factor that takes into account the degradation of lumen output of the light source. But what this means is that almost all lighting installations are designed to be overlit from day one and achieve exactly what is required just before maintenance occurs on the last day. Therefore, too much light is being provided most of the time, which means more energy is being consumed than is necessary. You can see from the graph, the red line here shows your desired, or what you require. So you require 80% of the 100% output from that fitting. The light blue line, which starts at the top and gradually comes down across the graph, that's what you will normally experience with most installations which don't use constant brightness. So you can see here that this is all effectively wasted energy. So now if you take a look at the navy blue line, this is the light output you'll get if you use a constant brightness system, which is much closer to the red line, and you mitigate all that wasted energy. So that concludes the webinar today. So if you have any questions for Ian or myself, please send them through. So thanks to all the viewers. There's now a survey, just a 30-second survey if you would like to participate, and thanks for your time. And Ian, there's a question on KNX. Maybe this is a good question for you to answer.
Thanks, Steve. The question for everyone else's benefit is, are KNX and lighting controls such as DALI and DSI mutually exclusive, or can they be used together? They can certainly be used together. In the KNX world, there is quite a number of products that operate with DALI. And it's interesting, in the control system of KNX, as we would with any other control system, we talk about a certain amount of points, and there are limits in the system so that you have a certain amount of points in a KNX system. It's actually about 65,000, so there is plenty. But one KNX point could be, or KNX node could be a DALI interface. So that one node on the KNX system will then be multiplying out and fanning out into all those Dali addressable locations. So short answer, yes, they can certainly be used together, and it is very, very common to do so.